Hello and welcome back for another VMK in the Caligari series. In this VMK, I'm going to show you how to texture objects within TrueSpace. If you're finding my videos helpful and you can support my website, you can do so by going to the store and purchasing any of the items there, buying a membership, clicking on the PayPal icon to make a donation, or just by clicking on any of the Google ads found at the side. Alright, so let's get started inside TrueSpace. I'm going to change my default view here to be a single view rather than a 4-split view because we won't need the other views to see how texturing is applied. Now, to work with textures, I'm going to start off with a cylinder, and I'm going to do something a little bit different here with the cylinder. I'm going to change the number of sides the cylinder has to 5, like so, and this is the object that we're going to apply a texture to. To apply textures to an object, you need to open up the material editor first. So we can do that here by clicking on the material editor. We see the current shader already drawn here on this little sphere, and if we just click on that sphere once, we get a square that represents that shader as well. If I just open this up to display the color channel, you see we have that gray color selected. A texture is actually a color shader. So what you need to do is have the color shader opened, right-click here, and this will open up the color shader picker. Down here you have all different kinds of shaders you can choose that will affect the color of your objects. And located here you'll see there's a texture map. This is the one we're going to be using to apply a texture. So let's select it, and you see that automatically it fills in the color shader part with the texture that's already loaded. And by default, it will always select the Caligari texture. If you want to change the texture that you want to use, all you need to do is click on this Caligari button, and it'll open up a little window where you can make selection as to what texture you want to use. But for now, let me just demonstrate how to apply this Caligari texture. As before, you can use these buttons on the side to apply this material to your object. So if I select this button here to paint our object, you'll notice that the object becomes painted with our texture. However, the texture is not really distinguishable. It seems to be broken up into many different pieces. If I rotate my object around, you can sort of make out maybe this is a G here, and this bottom part here I think is reading corporation, but it's not very easily readable. The reason for that is because the texture mapping that is applied to this shape right now is not really defined. It's whatever the default value is for our cylinder. So to define the texture coordinates, you need to use these buttons located over here. We have planar UV projection, cubic UV projection, cylindrical, and also spherical projections. Let's start off with the planar projection. The way that this works is when I click on the button, you see a plane appear on the screen. That's this section right here. If I move this plane, you can see I have a rectangle that represents our planar projection. And that rectangle actually represents the texture. So the texture itself is drawn out in this rectangle, and it's projected downward onto the surface of the object. And wherever the texture makes contact with the object, that's the way that it gets rendered. Imagine this as being sort of a silk screen with our texture on it, and you shine a light through that silk screen. Wherever the result hits your object, that's how it becomes textured. So that's the way that the texture mapping for UV planar projection works. And again, you can use the regular move, rotate, and scale tools to change the dimensions of this planar projection here. We can rotate it. We could also move it if we wanted to. That's not quite very useful for this object that I've selected. So now let's take a look at the cubic projection. Cubic projection is very similar to planar projection, with the difference being that we have a cube that each side has this texture on it. So now you see, as I rotate the orange cube, we can see the texture appearing a little bit better on each of the sides, but still not very easily distinguishable. Again, it's working exactly the same way that the planar projection is, where you have each of these faces from this cube containing this texture, and you can imagine a light shining through each of these faces, and the result is projected onto the surface. The cubic projection would work well if we had a cube object. We also have cylindrical projection. Here, this texture is actually mapped on the cylindrical section of the cylinder. You can see I can rotate the cylinder around, moving the texture, but there is no texture mapping really located at the top or bottom caps. It's just sort of merging into the very edge of this texture. So as I rotate the cylinder onto its side, you see that the top face of my five-sided cylinder here now becomes textured. So that's the way that the cylindrical mapping works. And spherical works in the same way that you would imagine if this texture is wrapped over top of a sphere. You would want to use spherical projection if you're modeling something like the Earth, and you had a texture map that represents the surfaces of the Earth. You'd use a spherical UV projection to project this square image onto a sphere. Cylindrical projection you'd use if you're projecting on something cylindrical, such as maybe a character's arm or leg. If you had a person's arm, you can imagine that being sort of a cylinder, so you can apply a texture all the way down the arm using a cylindrical projection. And cube, of course, you would use over any type of rectangular shaped objects. I began this tutorial with a five-sided cylinder because I knew that a five-sided cylinder wouldn't really work well for any of these four default shapes. So instead, I need to use another technique. And this other technique is actually the most useful technique that you will use in game programming. You most likely won't have simple geometries like a cube, a sphere, or a cylinder to texture. Instead, you might have things like a car, a biped character, some monsters, things like that. And those don't really project well using spheres, cylinders, or cubes. So instead, you need to use a different technique. Located at the very bottom here, you'll notice there's another button here, and when I highlight over top of it, it says Unwrap. If I use the left mouse button, click and hold, you'll notice that there's actually a couple other buttons located underneath. There's this one, which is the default one that you're currently seeing, Unwrap. There's also this one, UV Slice, and the last one, Shrink Wrap UV Computation. Alright, what do these do? Well, just like the planar, cubic, cylindrical, and spherical mapping, there's an algorithm applied whenever you click on this button. And the algorithm determines the UV coordinates for our shape so that you know how to apply the texture. Let's begin with the shrink wrapping tool. The way that shrink wrapping works is it takes your object, calculates a sphere that's bigger than your object, and then starts to shrink wrap the sphere. The sphere itself is going to start off being a texture map, just as if you were to use a spherical texture. However, as this shrink wrap starts decreasing in size, the wrapping gets tighter and tighter. I don't know if you'll see this in the video, but if you do this on your own, you'll see that there's a sphere that starts off and then it sort of shrinks wraps and grabs over top of your object. The result that you see is the final computation for all the UV coordinates. So that's what we see here. After it's shrink wrapped, you also have the ability to move the shrink wrapping around any way you like, just the same way that you could with the spherical, cylindrical, cubic, or planar mapping. So if you have some sort of closed shape that fits well inside of a sphere, you can use shrink wrapping for the texture coordinate computation. If the result isn't what you expect, then you'll have to go in and use the UV mapping editor, which is shown here. For me to demonstrate how this works, I'm going to switch my texture to be something more unique. So I'm going to go up here, click on the Caligari button, and if I scroll across, here's all the different textures I currently have in my TrueSpace texture folder. I'm just going to scroll across here to see if I can find a texture that has something interesting. Actually, this one here should work good. This texture is a sample texture you might find in any commercial game engine. If you look closely, you'll see that there's a character's head here, there's a character's body, front and back sides, and there's some other pieces as well, like there's some hands down here, ears, and so on. This texture map contains all the texture information for one entire character. This is actually the way that is recommended to create 3D models for games. Create a model and then use one texture to map out the entire image on top of that model. Now, let's apply this texture onto our 5-sided cylinder here. I'll just do a mapping like so, and you can quickly see that, again, the results aren't very helpful because you can't make anything out. Let's go into the UV mapping editor, and now I can show you how to specifically cut this up and pull out each of the object's faces and apply a texture to them. After you already have a UV projection on your model, you can click on the UV mapping editor and it will show the following. Your texture will show up in the background, and laid over top of it you will have all the faces that associate this object in the UV coordinate space. So here you can see as I move across, there's all these different faces that I can manipulate. In the UV mapping editor, located at the very side, there's also a bunch of buttons. These buttons allow you to make different kinds of selections. By default, you have your contact selection selected, so I'm going to change this to use face selection like so. Now as I highlight over top of our shape here, you notice that each face is selected. If I make a selection here, you'll notice that the selection turns green, and if we go back into this view, a selection also shows up showing that these texture coordinates map out to these object coordinates. Now if I use the Move tool, which is currently selected here, we can also change it to be a Rotate tool or a Scale tool, but we'll just leave it at Move. I can now go and click and drag inside here. As I'm dragging, you'll notice that the texture over here is updating. Right now I have it selected over top of this sort of gold region, so the gold region shows up. If I move all of these UV coordinates to be maybe over here where the guy's eyes are, you'll notice that the guy's eyes appear. Basically, what I'm doing is I'm saying that these UV coordinates are supposed to be mapped out, located here on the texture. And then when the renderer renders the result on the object, you see the texture portion that's over here mapped out to this section of the object. One thing that you may quickly notice is that the image inside the UV mapping editor looks crisper than it does here inside of our view window. To fix this, you can go into the File menu, Display Options, and located in here there's Texture Resolution. Right now I have it set to 128 by 128. If I click on this button and crank it up to maybe 512 by 512, you'll notice that this texture is now more crisp. It's a lot easier to see what is being textured here. So I'll leave it at 512 by 512. The other thing is that this face has other faces attached to it. And you can sort of see that because as I move this face that I currently have selected, the other faces that are adjacent to it are stretched as well. You may not want to have this happen. To prevent adjacent faces from moving as I move this face, all you need to do is click on this button here, Break Mesh Along Edges. As soon as you do that, you've disconnected this face, which is basically the texture mapping for this face located here, and now you can move it independent of how these ones over here are located. So I'll place this guy here over top of the eyes, just as demonstration. Now I'll make another selection inside of the UV mapping editor. Let's say I select this portion here. Well, this portion of the texture editor actually corresponds to this face here. So now I'm going to also detach this guy, and I can move him over to maybe, let's say, right here where the bottle is. I can scale this if I want, or shift it around, same way that you'd use the regular tools within TrueSpace. You can also go in here and select vertices, so now I can make a selection for one vertex and move it around if I want to, like so. and I can make precise adjustments to make this texture fit exactly to whatever it is that I'm trying to texture. I'll just turn back here to the face selection tool. Alright, I'll make another selection here. Let's say I want this face here now, and this one appears to be on the back side. And I'll also detach it, and I'll shift this over here to his hands maybe. And I can also rotate this around if it's not oriented in the right way. Now remember, because this image here is square and the texture coordinates are not, you will get skewing. If you don't want skewing in your image, you should make your texture coordinates to be perfectly square. There's a number of ways you can do this. You can go in here under vertex editing and actually edit each of these vertices to make it as square as possible, or you could also go back into our object view. So I'll select here, go into our object view, select this face, which corresponds to those texture coordinates, and with that one selected, I'll do a planar UV projection. As soon as I do that, you'll notice that this face's texture is now filling up the entire size of our texture. I can go in, select the scale tool, and scale this image down to be smaller, and now I've got a nice rectangular section and nothing is really being deformed as I highlight over top the hand now, like so. And I'll also rotate this around to be the other way. So you can see texture mapping can be a little bit time consuming, but that's just the nature of the beast. You can't really go about and do texture mapping quickly. It is a multi-step process. You need to figure out the face you want to texture, find the coordinates inside the UV mapping editor. Once you have them, then you can go in and manipulate them to be located to wherever you want for your texture. Remember, some of them may already be attached to other pieces, so if that's the case, you can go and detach them. So as you move this now, this other piece does not move with it. If you do want to go in and weld pieces together, so for instance, this one here, I just detached from this, this face here. If I wanted to go and attach these two together, what you need to do is make some vertex selections. I'll select this vertex here, and I want to attach it to this one here. So I'm going to click on both of these, so I now have both of these selected, and if I left click and hold, move over here to weld vertices, as soon as I let go, then those two vertices have now been welded together, and now they occupy the same space. So now when I go in and make a selection for this face, you'll notice that as I'm moving this face, it's also moving the shape of this face as well, because now those vertices have been welded together. So that's basically it for texture editing. There are a few other controls you can use here. Located at the very bottom, you'll notice there's a blue triangle. If you use your left mouse button, click and hold, as you move your mouse around, you'll notice that your texture moves. If you use your right mouse button, click and hold, as you're moving forward and backward, you're actually zooming in and out of your texture. Your texture is seamlessly mapping in all directions, so you can move your UV coordinates to be located anywhere you like. For instance, if I wanted this face not to be here but rather over here, that's perfectly fine. You don't have to place them all inside this one section here of the image. You can place them anywhere you like, and OpenGL as well as TrueSpace will know how to map out your texture for your object. Okay, there's only one other thing I really wanted to show you inside of the texture editor, and I'll do that by starting off with a new object. So let's just delete what we have here, and I'll reset our texture. The last tool I want to show you how to use inside the texture editor here is this one right here. Unwrapping. The way this works is it lets you unwrap an object and make it planar so that when you go in and texture it, it's a lot easier to identify which triangle is associated with which part of the object. Sort of similar to how this shrink wrapping tool works here, but shrink wrapping starts off with a sphere and wraps it down over top of your object. Whereas unwrapping, what it does is it starts off with your actual object and unwraps it and tries to make it flat. So to demonstrate this, what I'm going to do is I'm going to select a rounded cube. Just going to create this rounded cube like so. And if I try to click on unwrapping right now, you'll notice it brings up an error message saying closed objects are not supported. You cannot unwrap an object that is completely closed. An object is closed whenever you can't get inside the object without having to go through a face. If you had a cut inside of this object that allowed you to go from the outside to the inside, then this object would not be closed and you could use this button automatically. But because I have a closed object here, I can't just click on this button and have it work. Instead, what you have to do is create a virtual hole. The way you do this is by clicking on this button, moving over to the UV slice. With the UV slice tool, you have a knife that you can use to specify where do you want your hole to show up. Well, I'm going to select this top portion here to say that this top square is going to be detached from my rest of my object. So in other words, this is where the hole is going to be so that I can then go in and unwrap my object. After you make this selection, you can go back into the Unwrapper tool and make this selection. As soon as you do that, you'll notice that there's an object on the screen that appears to be flickering. That's basically TrueSpace trying to take our object and spread it out in such a way that it optimizes the location of all the UV coordinates for this object. To see the results, just click on the UV mapping editor and here you go. You'll notice that the object has been planar mapped for us automatically, and all the coordinates have been sort of spaced out evenly as much as possible. The one face that's located at the very top here, which I cut out, ended up getting placed right at the very center of this UV projection. Everything else is still connected together, but laid out very nicely for us to go in and texture. Now if I were to go in and apply a texture to here, let's say we use a spider image, you'll notice that this spider shows up on our object very nicely except for this top face. And this top face is the hole that we cut out. Let me just move this image over here and flip this over. And you can sort of see that the spider is wrapped around entirely over top of the surface of this round cube. What I can do is go in here and just zoom out, make a selection for that interface, scale this guy up, like so, and actually I'm going to move it over to the side just so that things are not overlapping as much as they are right now. Now you'll notice that that spider is right here where that UV coordinates are for the part that we cut out. This spider here is mapped out over the rest of the image as shown here. If I wanted to go in and change how this mapping occurs, you can go in, use the selection tool to make multiple face selections. With all of these selected, I can go in and scale them maybe up a bit, like so. And now you can see we have multiple spiders appearing on each of the faces here, because we have multiple spiders now located on each of these coordinates for our UV mapping. So there we go. I just showed you how to use the automatic unwrapping tool, the cut tool so that you can use the unwrapping tool, the shrink wrap tool so that you can shrink wrap a closed surface, and also the default UV projection for planar, cubic, cylindrical, and spherical mapping. The only real important thing you need to know when texture mapping is that a texture map in the UV mapping editor is a two-dimensional representation of how a texture will appear in 3D.